Welcome back to our journey. It's on paper 3, option B, engineering physics. Question number 8. We finished A8 and now we go to 8B. If you like my sharing, remember like and subscribe. Support our little channels. We need your support. Thank you. So for part B, okay, it said that a two-blade model, okay, propeller is modeled like this, okay, really as stated in A3, and then you keep the data. Make sure this data is really the M and L is the length of each blade. Yes, I remember L is length. Mass of each blade, 2.2. Yes, I remember. So just a substitution, right? Substitution. So we just say I equals V over 2 over 3, m is 2.2, and then 0.60 all square. Remember the trick, okay, give you the answer, so you need to calculate more accurate work. So 0.5, yeah, 28, okay. Check again, 0.5, 28, yes, and then you said it approximately is 0.5. And then later on you can take it as 0.5. Okay, this is accurate enough. We'll use it again, so we have to get this thing up. Okay, remember I is here. Okay, I is here. Okay, 0.5 kilogram meter square. So next step, okay, we have parts C, 1, 2, and parts D. Okay, all are very good question. Okay, so first of all, look at the question again. Calculate your time taken for the two-blade propeller to reach the angular speed of this one. So we talk about the time. So you remember I have the change of angular speed. Okay, from what? Okay, R at west. Okay, so the delta omega is given. So how can you find the time? So remember R, you did the angular acceleration. So it has the torque. How can you find alpha from torque? You have the I here, right? So all the thing is ready, so you write down. Okay, so think before you write. Okay, tau equals I alpha. So you can say comma, okay, and then tau is 140 equals 0.5 alpha. So alpha is 280 unit. Angular acceleration, radian per second square. And then you remember, similar to the translational motion, okay, how to find the time equals change of angular speed over alpha, so it is 750 over 280. Calculate the time again, so it's 2.68 seconds. Always if not in question 1 and 2, physics is excellent. Got it? Good. Okay, move on to 2. Okay, calculate the number of revolutions of the two-blade propelled to reach the angular speed of 750. Okay. Number of revolution. It means a movement, right? It means you need to find out the feeder, the angle traveled, rotated by the system. So you need to remember just like translational motion, right? Theta equals omega naught t plus half alpha t squared. Okay, we have the t, we have the alpha, and omega naught is 0. So we've got all the way. Right, good. So start it. Okay, so we have to write 0 plus half 280 2.68 all square, and then calculate it. Good. 1005.5. So intermediate step, I will write more. It is a number of revolution? No. Radian, the angle. So you have to find a number of revolution. You remember a cycle is 2 pi, right? So it is 1005.5 over 2 pi, okay? Calculate that time. 160. So yeah, probably it's correct. The answer is so good looking. Okay. Last one. The propeller is brought to rest in 5 seconds. Rest. Okay. Brought to rest. Okay. Determine the average value of the external torque applied. From what? Oh, of course, from here. From the initial stable angular speed at 750. It drops to 0 in 5 seconds. So, yeah. The same thing, right? Tau equals I over. I is 0.5 angular acceleration. You can say magnitude deceleration. So 750 radian per second drops to 0 in 5.0 second. Sometimes it says on 5.0, so just copy 5.0, don't say 5, okay? So what's the result? 75. What's the unit? Tau, moment, force, time distance. Yes, Newton meter. Or maybe you forgot it. Copy it here. The unit always can be copied from the data given in the question, okay? But if you can remember it, then it will be a little bit faster, right? So this is the part D's answer. That's it. We make it, we go through question 8. Well done, guys. See you.